Okay, on page 97, we are going to talk about average rate of change. So last time we talked about rate of change and we said, hey, that's just slope. Most of the graphs that we looked at had segments that were lines, even if the entire graph was not a line. Today, we're going to look at average rate of change, which means even our segments may not be lines. We're still going to look at the slope between the points that we identify as our average rate of change. Okay, so again, we're finding slope today. So on page 97, we're going to start by finding the slope between some different points. These points are all on this graph. These points are all on this graph. I just want to make sure that we're looking at the right graph as we're finding our points. And so let's start by finding the slope between point A and point B. Okay, here's point A, its coordinates are 0, 3. Here's point B, its coordinates are 2, 4. And we're going to find the slope between those 2 points. Okay, so remember, when I find slope, y on top, x on bottom, and I want to line up the values that come from the same point, that come from the same coordinate. So this would be 3 over 0 minus 4 over 2. Remember, y on top, x on bottom. And then I want to simplify. 3 minus 4 is -1. 0 minus 2 is -2. Negative over a negative would be a positive. And then we won't simplify 1/2 anymore. There's nothing else for me to do there. I just have positive 1/2 for my slope. Okay. Same thing that we've done the last couple of lessons. Now I'm going to find the slope between points B and C. I know the coordinates for B. Here's C, its coordinates are 4, 5. And I'm going to find the slope. Y on top, x on bottom, so 4 over 2 minus 5 over 4. And then we simplify. So 4 minus 5 is -1. 2 minus 4 is -2. Negative over a negative is a positive. And I've got positive 1/2 for my slope there. And now my last set for this graph, I want to find the slope between point A and point C. Y on top, x on bottom, so 3 over 0 minus 5 over 4. 3 minus 5 is -2. 0 minus 4 is -4. Negative over a negative will give me a positive, and then 2 over 4 I can reduce to 1/2. What do you notice about all of these slopes? They're the same, right? So we're looking at a line here. The slope between any 2 points on my line should be the same. So the slope between A and B, between B and C, between A and C. If I pick more points here, the slope between any 2 points on a line should be the same, okay? The rate of change for a line is constant, okay? That's the slope. That's what the slope is representing, is that constant change that I'm seeing. So in this case, it's 1/2. So between any 2 pair of points, I can follow this slope. Now, if I've got a function that's not a line, we may see something different. So over here, I've got, this looks like a transformed y equals square root of x function. It's got sort of that endpoint and off to one direction. It looks like we moved it up 2 and maybe stretched it out a bit, but this looks like a square root of x graph. So we're going to find some rates of change between points on this graph. So we're going to start by finding the slope between D and E. D is at 0, 2. E is at 1, 4. So we're going to find the slope between those 2 points. Remember, y on top, x on bottom. So 2 over 0 minus 4 over 1. 2 minus 4 is -2. 0 minus 1 is -1. Negative over a negative is a positive. So my slope here would be +2, or if you wanted, +2 over 1. Now I'm going to find the slope between E and F. I've got the coordinates for E. The coordinates for F are 4, 6. So let's find that slope. Y on top, x on bottom, minus, y on top, x on bottom. 4 minus 6 gives me -2. 1 minus 4 gives me -3. Negative over a negative is going to give me a positive. And then 2 over 3 isn't going to reduce any more than that. So my slope here would just be 2/3, 2 over 3. And then finally, I'm going to find the slope between points D and F. So from D to F. Remember, y on top, x on bottom. So 2 over 0 minus 6 over 4. 2 minus 6 is -4. 0 minus 4 is also -4. -4 over -4 reduces to 1. What do you see with these slopes? They're different, right? So what we're finding here is the slope of that little stretch, the slope of this little stretch, and then the slope of the whole thing, right, from D to F. And each of these segments, if I look at them, have different slopes. That should make sense because I didn't draw one straight continuous line like I could have for our line, okay? And we, again, saw some examples like this yesterday, even though our graphs had sort of linear sections to them. But that's what we're seeing here. We have a non-linear graph, something that's not a line. We're finding the rate of change in between different pieces of that line, okay? Or of that graph, I should say. So again, we're still just finding slope, but we're calling it that average rate of change today because I'm not looking at a line that actually has a slope. So we're looking at how am I changing over these different sections. Now, at the bottom of page 97 is a box that's got a formula looking thing down here. I want to point out that this is the same slope formula we've been using, okay? So if I plug in, or if I have point A comma something and B comma something, okay? A and B would be my X values. And then this is telling me plug in B to find Y. So this is the Y that goes with B, and this is the Y that goes with A. This is the X value for A and the X value for that point B. This is just slope. This is not a new formula you need to memorize. This is exactly the same thing that we've been doing. Y is on top, X on bottom, line up the values that come from the same ordered pair, okay? Questions for me so far? Okay, turn the page for me. On page 98, we're going to look at average rate of change or slope. Again, just in some different sort of context, in some different ways. I will tell you that example 2 is going to be our hardest example for today because we'll have an extra step here. For our last example, we had the graphs for our functions. So when I wanted to find the slope between 2 points, I could just look at the graph and pick out those points. We've done some examples where I had a table, and so we could just look at the table and pick out the points that we wanted. We had some examples yesterday where we had all that information given to us in some sort of context. So all we had to do was pick the information out of that sentence or couple of sentences that we had. Example 2 is a little bit tougher because we have a function and we know the X values that we want. We don't have any information about the Y. So we're going to have to find the Y. So we get an extra step here that makes this just a little bit tougher. Okay, but it's still in our wheelhouse. It's still something that we can do. So for example 2, we want to find the average rate of change between x equals 1 and x equals 4 for each of the following functions. So that means my points here are going to be 1 comma something and 4 comma something. Okay, 1 comma something and 4 comma something. Now I don't know the y values. I know the x's and I have a function. How could I find y? I know the x, I know the function. What could I do to find the y? Yeah, plug that value in for x. So that's what I'm going to do here. So I'm going to plug in 1 for x. So I get 1 squared plus 4. 1 squared is 1. 1 plus 4 is 5. So I have the point 1 comma 5. And then I'm going to do the same thing with 4. So 4 squared plus 4. 4 squared is 16. 16 plus 4 is 20. So the points I'm using are 1, 5, and 4, 20. We have that extra step here to find those y values. Once I have my points, we're just finding the slope. Remember, y on top, x on bottom. So 5 over 1 minus 20 over 4. 5 minus 20 is negative 15. 1 minus 4 is negative 3. I can reduce negative 15 over negative 3. That would become positive 5. So there's my slope, positive 5. Now we're going to do the same thing for b. For b, we've got a new function here. I still want to find 1 comma something and 4 comma something as my points I'm going to use. So I'm going to approach this the same way. I'm going to start the same way. I'm going to take my x values, plug them into my function to find my y. We have that sort of added first step here. So this would be negative square root of 1 plus 3. What's the square root of 1? 1. So make that negative, and we've got negative 1. Negative 1 plus 3 is 2. So I have the point 1 comma 2. And then I'm going to plug in 4. So negative square root of 4 plus 3. What's the square root of 4? 2. Make it negative, and I get negative 2 plus 3. That gives me 1. So 4 comma 1 is my other point there. Now that I've got my 2 points, find the slope. Remember, y on top, x on bottom. So 2 over 1 minus 1 over 4. On top, 2 minus 1 is 1. On bottom, 1 minus 4 is negative 3. And I can't reduce this anymore, so my slope or my average rate of change would just be negative 1/3. Questions for me so far? Okay, let's take a look at C. Same idea here, okay? We're using those same x values. So I've got the point 1 comma something and 4 comma something. We have to start by finding those y values. So I'm going to plug in 1 for x in my function. That would be 2 to the first minus 1. 2 to the first would be 2. 2 minus 1 is 1. So I have the point 1 comma 1. And then I'm going to plug in 4 for x. So I get 2 to the 4th minus 1. Remember, 2 to the 4th means 2 times 2 times 2 times 2. Okay, I've got 4 of them that I'm multiplying together. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 2 to the 4th gives me 16. 16 minus 1 is 15. So I have the point 4 comma 15. And now I'm going to find the slope again. Remember, y on top, x on bottom. So 1 over 1 minus 15 over 4. 1 minus 15 is negative 14. 1 minus 4 is negative 3. I have a negative over a negative, which I can reduce to a positive. But 14 and 3 don't have any common factors. So my final answer here is just going to be 14 over 3. That's my rate of change or my slope. I want you to try part D. So you try D. Again, I know my points are 1 comma something and 4 comma something. So to find the y's, I'm going to plug in my x values. So this would be 20 minus 1 squared. 1 squared is 1. 20 minus 1 is 19. So I have the point 1 comma 19. And then 20 minus 4 squared. 4 squared is 16. 20 minus 16 is 4. So I have the point 4 comma 4. Now I'm going to find the slope between those 2 points. Remember y on top, x on bottom, so 19 over 1 minus minus 4 over 4. 19 minus 4 is 15. 1 minus 4 is negative 3. 15 over negative 3, I can reduce, since 3 is a factor of 15, we could divide this, and I would get negative 5 for my slope here. Questions on D? Okay. For the last problems that we're going to look at for today, we're using a table, and we did some problems using a table last time. So we're going to look at the, in this case, years that we're talking about, pull that information from our table and use that when we find slope. So for example 3, it says the average price for a ticket to a movie theater in the US for selected years is shown below. So here's our years, here's our price. Now, just like that homework problem from last time, the top line of our table is our X value, the bottom line is our Y value. So we have to be careful when we pull these pieces of information to set up our slope. A says find the average rate of change of ticket price with respect to time over the period from 1987 to 1999. Okay, so 1987 is here, 1999 is here. I'm going to find the slope between these 2 points. Remember, the x values are on top here, so I'm going to have to flip this when I set up my slope. So this would be 391 over 1987 minus minus 506 over 1999. For this last example, bless you, you are probably going to want your calculator. We're going to have some kind of weird division as part of our problems here. So if you need to pull out your calculators on these, that's just fine. So if I just go ahead and type this whole thing in my calculator, I would end up with 0.095, and it keeps going after that. But I'm going to stop at that third decimal place and remind you that we are talking about money. How many decimal places make sense when I talk about money? Decimal places. 2, right? Nearest penny, okay? So here would be my second decimal place. I want the third so that I know how to round. Since I've got 5, I'm going to go up. So 9 would round up to 10, and we would be looking at 10 cents per year. So this means that over this 12-year period, movie ticket prices went up about 10 cents per year. For B, we're using the same information. We're just finding that rate of change over 2 different years. This time we're going to look at 1999 and 2009. So 1999 and 2009. Remember, money is on top, so this would be 506 over 1999 minus minus 750 over 2009. And again, you can throw this in your calculator. We're going to get some decimals again. Decimals that we'll have to round. When I type this in, I should get 0.244, and then I'm going to stop again after 3 places so that we can round to the nearest penny. Since my third number is a 4, we know that we're going to stay. So I'm looking at 24 cents per year. So over this 10-year time frame, our ticket prices increased by about 24 cents per year. I want you now to try part C. We're looking at the period from 2007 to 2016. So I'm going to find those in my table. And then remember that Y value, in this case, our money is on top. So 688 over 2007 minus 866 over 2016. When we divide this, we get 0.197, blah, blah, blah. Round to 2 decimal places. This 7 is going to round us up. So 19 rounds up to 20. So our movie ticket price is changing by 20 cents per year on average over this time frame. Questions for me for today? Okay, your homework is on pages 99 and 100. You're looking at the same types of problems that we saw today. So you have a graph, you have a table, you have some problems where you'll have to plug in those X values to find the Y, just like we did together in our notes.